Hi friends, welcome to Inspi Genius for JEE. My name is Abhishek Tiwari and in today's session I am going to discuss the paper IIT JEE Mains that was held on 7th of January. So according to me that paper was quite balanced way, means some questions are easy, some lie in the middle and few questions are toughest too. So before we take up the paper, I will just like to segregate the questions which has been asked in the paper from the topics. As in the optics, these are 3 questions, modern physics 3 questions, electromagnetism 7 questions, thermodynamics 4 questions, waves and oscillations 2 questions, and mechanics has 6 questions. So these are the questions. So let us start with the problems. So the first question that has been asked in the paper for this particular set is the magnetic field in a plane electromagnetic wave is given by B equals to this much Tesla. Then what is the expression for the electric field? I think this question is very much easier. Means you have to find the expression for the electric field, and we all know about the relation between the B and E. B और E का बहुत easy relation हम जानते हैं. वो क्या होता है with the velocity of light. Yes, velocity of light means that c equals to, as we say, c equals to ratio of what? Ratio of electric field to the magnetic field. From here the question becomes very easy. Thus we have to find the electric field C into B, and B has given in the problem, so we just write as E vector is equal to C is 3 into 10 power 8 meter per second, that we all know, and the B is given 3 into 10 power minus 8 sine of 1.6 into 10 power 3 x plus 48 into 10 power 10 t in j cap. So this is the answer we have got from that 9 sine 1.6 into 10 power 3 x plus 48 into 10 power 10 t, and this expression is what is the direction of the E. As we know that the direction is perpendicular to this, so I j k, it is the k function, so the answer will be the fourth. This is the correct answer for this particular question. Let us solve the next problem. This problem is from the atomic structure, that is atom and nuclei. The question is about the time period of the revolution of the electron in its ground state orbit in hydrogen atom is 1.6 into 10 power minus 16 seconds, and the frequency of the revolution of the electron in its excited state. We have to find the frequency of the electron in the excited state. As we know that the time period, what is the time period relation? We know the time period relation as T is directly proportional to N upon Z, N cube upon Z square. So time period in the ground state is given. We have to find the frequency. We also know that the frequency is inversely proportional to the time period. Here just only we make the T1 to the T2 ratio. We put N1 upon N2 whole cube, as Z equals to 1, because hydrogen atoms Z equals to 1. Simply just put the values. T1 is 1.6 into 10 power minus 16 upon T2, that's equal to 1 by 2 whole cube, and by solving this we get frequency, that is F2 equals to 1 by T2 is F2, and we get the value as 7.8 into 10 power 14 second. So in this the option 3 is the correct answer. Let us come to the next problem. In this problem, it is from the magnetic field. Consider a circular coil of a wire carrying constant current I forming a magnetic dipole. The magnetic flux through an infinite plane that contain the circular coil and excluding the circular coil area is given by phi I. The magnetic flux through the area of the circular coil is given by phi O. Which of the following option is correct? We have to find the what is the option in this case correct. The problem, what is the problem is saying? अगर हम यहाँ पे देखें प्रॉब्लम सिंपली वो क्या कह रहा है कि अगर हम एक इनफाइनाइट प्लेन शीट लेते हैं, लेट अस ड्रॉ द इनफाइनाइट प्लेन शीट is a part of a infinite plane sheet in which a circular coil is placed. Now the magnetic field that is coming from this, if a current is flowing, what will be the direction of the magnetic flux? What will be the direction? Yes, it is a anti-clockwise. We can say it is going from inside like this. So this is the line of forces, magnetic line of forces. So number of lines that are coming from inside the circle must equal to the number of lines, field lines, magnetic field lines going out of the circle. So we can say from here that the phi I is equal to phi O, but the direction is opposite. Can we see the direction from inside is like this and outside is like this, so it is in opposite direction. So the option here we can see phi I equals to negative of phi O. So option 3 is the correct answer in this problem. Let us come to the next problem, and the problem is from diffraction, that is the wave optics. Visible light of a wavelength 6000 into 10 power minus 8 cm falls normally on a single slit and produces a diffraction pattern. It is found that the second diffraction minimum is at 60 degree from the sector maxima. If the first minimum is produced at theta 1, then the theta 2 is close to, then theta 2 is to be found. Let us see what are the situation they had given. But before that, this question is from the diffraction. We simply know for the minimum condition what will be the formula we are using. Yes, that is d sine theta equals to n lambda. This is the equation that we use for the minimum condition. So for the first case, as for the it is given the second diffraction minimum is given, so we just put the values as d sine of 60 degree upon d sine theta equals to 2 lambda upon lambda. This is for the second diffraction. We get 60 degrees, so we just put the 60 degree for n lambda, n equals to 2, and for the first it is given for the first minimum, so n equals to 1. From here we get the value of sine of theta, that is equal to root 3 by 4. As we all know, the sine 60 degree value root 3 by 2. So if we solve this fraction, we get 0.43. You know the value of sine 30 degree, the value of sine 30 degree is 0.5. So this angle should be less than 30 degree. The value is 0.43 and the sine 30 is 0.5. So from this options we can see that the nearest value that can below the 30 degree is the 25. So here the answer is 25. So first option is the correct option. So next problem is from the moment of inertia. the radius of gyration of the uniform rod of a length L about an axis passing through a point L by 4 away from the center of the rod and perpendicular to it. So we have to find this radius of gyration. In this question we have to find the radius of gyration. So let us make, if this is passing through center and the distance between this is L by 4, let name it y dash. From the equation, we can say the radius of gyration is I y dash is equal to m k square, where k is the radius of gyration. Now putting the parallel axis theorem, as it is shifted from parallel L by 4. So what will be the equation? What will be the equation that you can see that comes to be I y dash, that is equal to, we have to find the from this axis y dash, that is equal to m L square by 12, that is moment of inertia of the rod, plus the m L by 4 whole square. Now simply we put the equation as, solve as 7 by 48 ml square. This is the I y dash. Now comparing this with this equation, we get the value as 7 by 48 ml square equals to mk square. Cutting out the m value, and we get the value of k as under root of 7 by 48 L. So here we can see the option 1 is correct option. Let us solve the next problem, that is from the Newton's law of motion. A 60 HP electric motor lifts an elevator with a maximum total load capacity of 2000 kg. If the frictional force on the elevator is 4000 Newton, the speed of the elevator at full load is close to, that we have to find what is the speed of the elevator when the load is completely full. So let us solve for this problem. Let us, the elevator is moving with velocity v. If it is moving with velocity v, and what are the forces acting on this elevator? इस elevator के ऊपर अगर हम देखें तो क्या क्या forces लग रहे होंगे? डाउनवर्ड फोर्स कौन कौन से लग रहे होंगे? एक तो उसने फ्रिक्शनल फोर्स बताया था, फ्रिक्शनल फोर्स प्लस दी वेट. सो फ्रिक्शनल फोर्स और वेट इज इक्वल टू एम जी. हम यहाँ पे अगर हम ड्रॉ करें, डाउनवर्ड फोर्स जो लग रहा है दैट इज फ्रिक्शनल फोर्स प्लस दी weight. So net force that is equal to the frictional force that he has given is 4000 plus the weight is, mass is 2000 into the gravity is 10. So it is comes out to be 24,000 Newton. So this is the total force acting on the elevator downward. So from the relation for the power is equal to force into velocity. We can say the velocity is equal to power upon the force. Power is given 60 HP. Note here that we have to convert that HP, horsepower, into the wattage. So 1 horsepower equals to 746 watt. So it comes into the watt. The force we have calculated is 24,000. On solving this, we get the value as 1.9 meter per second. So here the option which is correct is 1.9. So option D is correct option. Let us solve for this problem, that is electric field. Two infinite planes, each with a uniform surface charge density sigma, are kept in such a way that the angle between them is 30 degree, and the electric field in the region between is that we have to find out what is the option. The 4 option has given, we have to find out the correct option. So in the figure you can see these are the 2 plates which are made at 30 degree. So we have to find the electric field between this. This is the 30 degree. This is the 30 degree. From this figure we can say that the electric field from any plate, infinite plate, is perpendicular to this. So this is the electric field, and the electric field to this plate is this. We have the same sigma charge density, electric field will be same. So the angle, this is 150 because this is the perpendicular, this is the perpendicular. The half of this is 75 degree. 75 degree by using the trigonometry. This is also comes to be 75 degree. Then this angle is the 30 degree. So in this question, as you can see, the option is in y and x cap. So we please note that you have to find the answer in x cap and y cap. So we have to move accordingly. Now let us see how we do it. As you can see, the electric field is in this direction, means from the lower plate, which is horizontal, and inclined at 30 degree is in this direction. So these are the electric field, respective electric field. If we draw the perpendicular in the same way, we had already find this angle is 30 degree. So what will be this angle? What is the angle of this? This is the, if we take, this is 30 degree, so it is E cos 30 degree, and the vertical component is E sin 30 degree. So these are the, we have already make it out for the x component and the y component. So net electric field will be the I cap and J cap. Let us find along the x, electric field along x. So x direction is this. So this is E cos theta. E cos theta only, no other component will be there, where E cos 90 degree is 0. So can be written as, because it is in negative direction, so put negative, so minus E cos 30 is 1 by 2 minus E by 2 I x cap. X cap is in the x negative direction. Now in y component is, this is E sin theta and E. So vertical up is E minus of E sin 30 degree. So this is the value net electric field. We make it out as E 1 minus sin 30 is root 3 by 2, and it is in y direction, so we put as y cap. Net electric field, what is the net electric field? Yes, net electric field is the x and y. So minus E by 2 x cap plus E 1 minus root 3 by 2 y cap. We can rearrange, but the question is not only this much. They had given that the E is equal to, what is the electric field for the infinite charge? It is equal to sigma upon 2 epsilon naught. We just put the values into it and we get the net electric field as, we take it E common and E is put the value of E 2 epsilon naught, and we get the inside value, that is we take a positive side, 1 minus root 3 by 2 y cap minus of x by 2, this is cap. So this is the answer. Let us check the option that comes to be this minus x by 2. This is not correct. This is, so this is this the only answer. So let us take the next problem. It is from the gravitation. A satellite of a mass m is launched vertically with an initial speed u from the surface of the earth. After it reaches the height r, that is the radius of the earth, it ejects a rocket of a mass m by 10, so that subsequently the satellite moves in a circular orbit. The kinetic energy of the rocket is, we have to find the kinetic energy of the rocket. Let us see what are the options. Options are in the form of this. So how we have to calculate the kinetic energy of the rocket? We simply know that the kinetic energy of any object is half mv square. Mass is given, mass of the rocket is m by 10. Just we have to find the velocity of the rocket. But you can see the velocity, as you can see from this graph, as a satellite is ejected from the surface of the earth. This is the surface of the earth. When the satellite has been launched from the surface of the earth, it will reaches to the height r. So this is the satellite and reaches to the height r. And start, what is this satellite will start? Satellite will start moving with some velocity that is called the orbital velocity. Okay, this is the orbital velocity. Now we all know what is the orbital velocity, that is gme by r. This is the orbital velocity. Now you can see, as soon as the rocket has reaches to the height of r, it has launched the satellite has reaches to the r, it has launched the rocket. Rocket has two velocities now, it is vy and vx. Now we have to find out the vx and vy of the rocket. We simply find the magnitude of this velocity, net velocity, and put it into the kinetic energy formula. So let us start with this problem. I think it is very much clear that what the problem is about. So let us make it to solve. As on the surface, at surface, if we see at the surface of the earth, at surface of earth, what will be the total energy? Total energy is nothing but the kinetic energy plus potential energy. Kinetic energy of the satellite is half mu square, and that of the potential energy is minus g m e m over r. As it reaches to the height r, then the total energy will be half m v square plus, we just negative of this, g m e m over 2r. So this is the total energy of the satellite by energy conservation. What we know about the energy conservation, that energy can neither be created nor be destroyed. It means the total energy will remain the same. So total energy means at the initial, on the surface of the earth, the energy is half mv square minus g m e m over r, that should be equal to 1 by 2 m v square minus g m e m over 2r. So this is the equation that we have found from the energy conservation. Now only the term that we have to calculate is velocity of the satellite. So v that comes out by solving this is under root of u square minus g m e upon r. So this is the expression that we have calculated for the velocity of what? Satellite. Now coming up to the rocket, as it will reaches to the height, what will be the velocity of the rocket. Now rocket has started moving with some velocity, but it has the two component, means rocket has y component and the x component, vy and vx for the rocket. From here we use the momentum conservation, means now what will be the momentum conservation? We just calculate, as it will be mass of this will be m by 10. Let us change the, this is m by 10. So what will be the momentum? Mass into velocity. So here the momentum will be calculated as the horizontal and vertical, means in x direction and in y direction. So conservation of momentum says that the momentum before the ejection, that should be equal to the momentum of the before. तो रेडियली अगर हम इसको देखें, मोमेंटम क्या होगा? रेडियली मोमेंटम क्या होगा? एम वी इक्वल्स टू एम बाई 10, पहले तो पूरा सैटेलाइट का था, एम बाई 10 इंटू वी आर. सो दिस इज द रेडियल वेलोसिटी. वी आर इज इक्वल टू 10 root of, we just put the value of velocity that we have obtained from here. We just put the velocity, that is u square minus g m e upon r. So this is the radial velocity that comes out. Now what is the second part? The second part is we have to calculate the tangential velocity. This part, tangential velocity of rocket. The momentum before and after will be the same, but before the tangential velocity is what? 0, and the horizontal velocity of what? The before ejection is 0, and after ejection it has mass of the rocket into v tangential. So just put the also tangential, and remaining mass is what? 9 m by 10 of the satellite. Satellite is moving now with the orbital velocity, that is under root gm by 2r. So here we put the values and we get the value m by 10 vt, that is equal to 9m by 10 into v naught. The tangential velocity equals to, cancel the mass and mass, and 10 to 10, and putting the values to 9. v naught की वैल्यू क्या होगी? क्योंकि ऑर्बिटल वेलोसिटी है तो ये हो जाएगी gm mass of the earth upon yes 2r. Now it is at the height of 2r. So this is the, what is the tangential velocity? We have to find out the kinetic energy of rocket. Kinetic energy of the rocket is, just we have to put the values in 1 by 2. m by 10, the mass of the rocket, is vt square plus vr square. On substituting these values we get the as 1 by 2, we can say simply with m by 10. vt की वैल्यू यहाँ से डाल देते हैं. vt square means it is going to be sorry 81 g me by r plus VR. VR is what? We just put the values of 100 u square minus gm e by r. So this is the value. On simplifying, we simply get the answer as, we put the values as and we get the option as U square. We get the option. We got the option for 5m U square 190 G by R. So option 2 is the correct option for this. To now start with the new question, that is from the wave optics. A polarizer analyzer set is adjusted so that the intensity of the light coming out of the analyzer is just 10% of the original intensity. Assuming that the polarizer analyzer set does not absorb any light, the angle by which the analyzer need to be rotated further to reduce the output intensity to be 0. As from the question we know, when the axis of the polarizer to the analyzer are placed at 90 degree, then the intensity of light coming from the analyzer will be 0. So here the question has little bit shifted from the position that the polarizer is not at perpendicular to the axis. If we take the horizontal axis, it is little bit making some angle, and with that angle it has 10% of intensity, means the analyzer is just 10% of the original intensity. If you can see in this problem, let this be the phi, and this is the axis. This is the polarizer axis of the plane polarizer. So this is the axis. We have to find this phi. If the intensity at this position is I naught, and तो इस पे कितनी हो जाएगी? Intensity is I naught by 10. Why? Because the 10% of the original intensity is. Now we have to calculate this angle. Means at what angle it has to be? The angle by which the analyzer need to rotate further to reduce the output intensity to 0. So further, if we have to move, we have to calculate the angle. So from here we can say, let us solve mathematically. By we use the Malus law that says that the I intensity is equal to I naught cos square theta. Here we had used the phi, so this is cos square phi. So intensity after making some angle, it is going to be I naught by 10. We have to find that angle I naught cos square phi. So cos phi is come to be cos square phi, we can say cos phi is come to be under root of 10, which is the approx value as 0.3. In this sheet we can see that we have calculated this angle phi. The phi has the value, cos phi has come to be value as 0.3. Now cos phi has 0.3. We know that the cos of phi is equal to 0.3, and we also know that the cos of 45 degree, that is also 1 by root 2, that is approximately equal to 0.7. If we know here, we have to understand the basic concept that this value, the theta for cos function, it will 0 degree to 90 degree. It is going from 1 to 0. So it means at 0.3 means that theta should be, or phi should be greater than 45 degree. If it is greater than 45, this angle is greater than 45 degree, then this phi is greater than 45 degree, then this is less than. So in option we have seen that the 45, 90 and 71 all are greater or equal to 45 degree. The only left option is 18.4. So the option that remains is this. So this is the answer for this question. So coming to the next question, that is electromagnetism. A long solenoid of a radius r carries a time t depends current it equals to I naught t 1 minus t. A ring of a radius 2r is placed coaxially near its middle during the time instant when t is greater than or equal to 0 and less than or equal to 1. The induced current IR and the induced EMF VR in the ring changes. So changes means it has four options. We have to opt for the correct one. Now the question has asked for that you have to find the induced current and induced EMF where when the ring changes during the time take instant, that is t is lying between 0 and 1, the induced current IR and the induced EMF VR in the ring changes का मतलब क्या हुआ, at a point the current will goes reverse direction का मतलब ये हुआ कि EMF will be 0. Once the EMF will becomes 0, then the current move in the reverse direction. We have to only apply this rule. I think this question is little bit shifted to the difficult one. Let us solve the problem. Let us clear the problem. If we say the this is the solenoid. This is the solenoid in which a current start moving, and we have to put that ring over this. The current ring is put over this of radius double to this. Radius of this is r, then the radius of this is 2r. Now the current start moving from this solenoid. We know that the flux that will brings out in the solenoid is by P. Flux equals to B dot A. So B dot means it is BA because cos is 0, so flux will be 0. Now we have to just put the value of B. What is the magnetic field due to the solenoid? We know that the magnetic field due to the solenoid is mu naught n I. This is the magnetic field, mu naught n I. Into the area. Now what is the area? What area you are going to put? Should we put the area of this ring or should we put the area of this coil? Because the magnetic field outside this coil is 0, so we just put the area of this ring only, means this coil only. So pi r square. So be careful by putting the area of the flux. The flux only generate through this solenoid. So we just make it more simpler. Mu naught n I. We just put the value of I. I is given as I naught t 1 minus t and pi r square. So this is the phi. Now what is the EMF? EMF from the d phi by dt. This is the equation which we put and we get the EMF minus, we have to make EMF as this is the mu naught n I naught pi r square to t minus 1. Here we differentiate the flux and we get this expression. Now where the current goes to reverse, it is going to be reverse when E equals to 0. And when E is equal to 0, when this function is 0, but here all the terms are constant. Here all terms are constant. So only 2t minus 1 is not 0. So make it to 0 and we get the answer t equals to 1 by 2, which is 0.5 seconds. So let us check for the option. The option is, this is the option, that at 0.5 direction of IR reverse with the VR equals to 0. So B is the answer. So next problem is from the kinetic theory of gases. The question is 2 moles of an ideal gas with the Cp by Cv is 5/3 are mixed with the 3 moles of another ideal gas with Cp by Cv as 4/3. Now we have to find the Cp by Cv of the mixture. Means we have given 2 gases whose are going to mix, which have the 2 moles and 3 moles. So let us solve for this, as we know that the Cp by Cv for gas 1 is given as 5/3 and Cp by Cv for another gas it is given by 4/3. So we have to individually find the Cp and Cv for the respective gases. That is for the gas 1 whose number of mole equals to 2. So Cp for this is by using the formula of R gamma minus 1. We just put the values into it and we get 5/2 R. Similarly, we get the Cv value, that is equal to, we put in the formula R gamma minus 1. We get the value as 3/2 R. So these are the value for the gas 1. Now the gas 2, Cp, again we put the value in the respective formula and we get as 4R, and this Cv as 3R. Now here we have calculated for the each gases 1 and gas 2, the Cp and Cv. For the mixture we have to find the for Cp by Cv. So Cp by Cv for the mixture is calculated by Cp mixture upon Cv mixture, that is gamma mixture, which is equal to, we just put the value for the respective gases moles and their respective Cp value. The formula here is N1 Cp1 plus N2 Cp2, putting the values for the Cp. Now Cv as N1 Cv1 plus N2 Cv2. We put the respective values from the data. We have already, all the data is given. We have already calculated for the Cp and Cv for the individual gases. We just put the values and we get the answer as 1.42. So option 1 is the correct option for this question. Now this question is from the logic gates. Logic gates is it's covered under the semiconductors chapter. Here you can see the question has asked which of the following gives the reversible operation. We have given the 4 logic gates and you have to opt for the reversible operation. Before opting this, you should know what is the reversible operation. If you are very much clear about the reversible operation, then there is no difficulty to take the correct option. The reversible operation is that in which we can easily trace out the input values by seeing the output values. So the NOT gate is the only gate here we can easily see the easily can get the input values by seeing the output values. So I think the option 4 in this case is the right option. So the coming problem is from the properties of solid. Let us see what is the problem is. The speed of the transverse wave on a straight wire, where the mass of the wire is 6 gram, and the length of the wire is 60 centimeter, and the area of cross section of the wire is 1 mm square, and it is the speed is 90 meter per second. If the Young's modulus of the wire is 16 into 10 Newton per meter square, then we have to find the extension in wire natural length. So what is actually problem? The problem consists of the two things, that concerned to the wave and the properties of solid. We know for properties of solid that the Young's modulus formula, that Y equals to force into length upon area into delta L. Here the delta L we have to find. Delta L. Thus the force has given, so we have to find the force. Force is nothing but the wire. In the wire we have put in the tension. Force is nothing but the tension, and which is equal to the mass per unit length into the velocity square. So we just find out the force by putting the mass, velocity and length. The data has already been given. Now we have to find this T, L, A and delta L. So delta L equals to TL upon AY. We put the value of T, that is M by L V square into L, that is area, and this is Y. Just cut out the factors and we get delta L as mv square by AY. Here we know the each and every data that has been given in the problem. That is, we know the mass, we know the length, that we can the area of cross section, we know the velocity, and we also know the Young's modulus. So it is very easier to put the values and get the answer. But one thing should be remember, all units are in different. It is gram, it is centimeter, it is meter, millimeter, and this is meter. So make it in the one unit and find the answer. From here it is in millimeters, so the option 1 comes to be 0.3 mm. Here the option is written wrong, so make it correct. It is 0.3 mm for this particular problem. So the next problem is from the rotational dynamics. As you can see in the figure, the bob of a mass m is tied by a massless string whose other end portion is wound on a flywheel disc of a radius r and the mass m. When released from the rest, means a bob has released from the rest, it starts falling downward. When it has covered a distance as the angular speed of the wheel, we have to find the angular speed of the wheel. So what will be the angular speed of the wheel in this case? Let us check for the values. It has the mass m having the radius r. When it start falling down and covering the height h. So here we simply use the energy conservation. By using the energy conservation we can solve this problem, or you have other way also by using work energy theorem, but I think energy conservation theorem is a very simpler one. So let us solve for it. As you can see, a mass is released from height h and reaches to the height h. So the potential energy is converting into the kinetic energy. We can say potential energy at the height h is mgh, which is converting into the kinetic energy, that is half mv square. But there is one more energy because that disk has a mass m and the moment of inertia. So we also put that energy 1 by 2 I omega square, that is a rotational energy. Rotational energy, if we consider for the rotational energy of r, the velocity v, we can say omega is equal to v by r. So here we can substitute the value of v as r omega in the equation. Simply putting the values in the equation, we get sorry, plus 1 by 2. What is the moment of inertia? Moment of inertia for the disk is mr square by 2. We just put the value mr square by 2 and it is the omega square. mgh 1 by 2 m, we put the velocity as r omega square plus 1 by 2 mr square by 2 into omega square. Simply solve this equation and from here we can easily get omega equals to 1 by r under root of 4gh by 3. So this is the option. I think 1 by r, this is the correct option. So one more question on the alternating current that is combined with the SHM. This problem has been combined with the oscillation. What is the problem? That the LCR circuit behave like a damped harmonic oscillator. Comparing it with the physical spring mass damped oscillator having damping constant B, the correct equivalence will be, means we have to find the correct equivalence for the LCR in terms of the mass and the respective parameters. So there are two different cases in which one is a LCR, another is a mass spring case. Let us first take the mass spring case. Mass spring case, if you get the mass and spring case, we can say in case of the spring mass case, the force is directly proportional to the kx minus kx, that is equal to the minus kx, that we call the restoring force. But here the terms used as the damped constant, so we also the minus bv, that is the velocity. So we have to make it into the differential form, that is we can write F is equal to mass into acceleration. Acceleration is nothing but the d2x by d2 square, that is equal to minus kx minus b dx by dt. So this is the equation that has came. We make it one side, but m d2x upon d2 square plus b dx by dt plus kx, that is equal to 0. Now coming to the LCR case. In LCR case we can write N di upon dt plus I into R plus, for the capacitor we can write Q by C, that is equal to 0. In terms of Q we can make as d2q by dt square plus dq by dt into R plus Q by C. So this is the differential equation in terms of the LCR, and this is the differential equation in terms of the mass spring ratio. Now we have to compare these two equations with the respective orders. So here we find that M reference to the L and B comes to the R and K represent to the 1 by C. So from here we can say the option that going to be L is M, C is K. So option C means this is correct. Again, it is a very simple problem from the center of mass. In this, the 3 point particles of a mass 1 kg, 1.5 kg and 2.5 kg are placed at the 3 corners of the right angle triangle of the side 4 cm, 3 cm, 5 cm as shown in the figure. Find the center of the mass of the system. We have to only calculate the center of the mass of the system. In this, it is a very simple problem that has been asked. So let us solve this for the center of mass for a system. That can be by, if we have a 3 masses, we can m1 x1 plus m2 x2 plus m3 and x3, this whole being divided by the total masses. We just plug in the values. Plug in the values means, if you can see in that problem, only in x direction on x-axis 1.5 kg of mass is placed at the 3 cm. The rest are on the x value is 0. So rest positions are 0. The total mass combines to be of comes to be 0.9. Now YCM for this respective value, m1 y1 plus m2 y2 plus m3 y3, and this combined divided by the equation, the total masses. Again, we can see on x-axis 1.5, that is 0, on origin that is 0, on y-axis only the mass that has been placed is 2.5 kg. So at 4 cm, the total mass is 5. Here we have calculated as 2. So the option for center of mass is 0.9 for the x and the 2 for the y. So the option that comes, that is correct option that has to be is A, which is 0.9 centimeter right, means it is x, and 0.2 centimeter above, this is y. So the y center of mass is 2 and x. So option A is correct. Now this question is from the current electricity, in which we have to find the current through the 1 ohm resistor. So you can see a figure in which this battery is supplying for the 1 volt and the respective branch has the individual resistors. So we have to find the current through this 1 ohm resistors. Now let us solve for this. If you can see, we can simply find the equivalent resistance of this circuit. Equivalent resistance of this circuit comes to be like this. The equivalent resistance is, this is 1 and 1 parallel, come to be series, the 5 by 2, and this is in parallel, then 2, this is come to be 10 by 9 ohms. So here the current flowing from the battery is I is equal to V by R, V is 1 and R is 10 by 9. So simply here we get the 9 by 10 amperes from the circuit. So the current flowing from this circuit is 9 by 10 amps. Now in this circuit, the current now distributed in the following branches, that it be I2 and this is I1. But here one thing more, यहाँ पे हमें एक चीज़ और दिखाई दे रही है कि अगर हम इसको देखें, ये पॉइंट को अगर हम देखें कि ये पॉइंट्स जो हैं वो these are having the same potential upon these branches. So 1 volt, 1 volt, 1 volt. If you individually take the IR, it is come to 1 volt. So this is A and this is B. The equivalent resistance through this is again 1. This is come to be 5 by 2. This is 2 ohms. This is the battery attached to this circuit. So the current I2 is flowing through 5 by 2 and the potential difference between is 1 volt. We simply get I2 equals to V by R. V is 1 and R is 5 by 2. Simply we get 2 by 5 amps through this. Again, if we reverse to this equivalent circuit into these parts, we get the 1 ohm, 1 ohm. They have the same resistor value, so the current will divide it equally among this. So it will have a distribution, means half of current. Now the current through the 1 ohm resistors will be the half of this, means it is 2 by 10, which is equal to 0.2 amp. So 0.2 amp is the correct answer. So option 1 is the correct answer. And now the problem is from the optics, and it is a very simple problem that you have to plug in the values in the formula and you get the answer. If we need a magnification of 375 from the compound microscope of a tube of a length 150 millimeter and objective of a focal length 5 centimeter, the focal length of the eyepiece should be close to. We have to find the what is the focal length of the eyepiece in this case. So let us do this problem. Be careful to put the values and be careful to put the datas in the same unit. Here we have to find the focal length of the eyepiece. So we use the magnification formula as L by f naught 1 plus D by Fe, where Fo is the objective focal length and Fa is the eyepiece focal length, and D is the least distance of vision, that is equal to 25 centimeter. Here we know that the D is equal to 25 centimeter. Now the only thing we have to do is the plug in the values. The magnification is 375, length of the tube is 150 mm, focal length is 5 centimeter, that is equal to 50 millimeters. 1 plus 25 centimeter means it is 250 millimeters, and obviously we have to find the Fe. So here we are going to calculate the Fe as, by simplifying this, we calculate as 2 mm approximately. So here we get the option B as the correct one. So the new problem is from the thermodynamics, in which 1 liter of dry air at STP expand adiabatically to a volume of 3 liters. If gamma is 1.4, what is the work done by air? We have to find the work done in this, and this process is adiabatically. Please note that the process is adiabatically. So this 1 liter of dry air at STP, the condition that is given, initial condition was STP. So we have to be very much clear about what is the STP condition. Here the STP means the pressure is 1 atmospheric and the temperature is 0 degree Celsius or a 273 Kelvin. So we take from ourselves by our knowledge that at STP what are the pressure and the temperature. So let us start with the problem. In this, as at STP, the pressure P1 is 1 atmosphere and the temperature is, I take in Kelvin as 273 Kelvin. Now it has said that adiabatically it has increases volume by to the 3 liters. So we can say in adiabatically PV raised to power gamma is constant. So initially it is P1 V1 raised to power gamma equals to P2 V2 raised to power gamma. We just simply put in the values as per the questions. The P1 is 1 atmospheric value at the initially 1 liter, gamma is 1.4, P2 we have to find, and V2 is 3 power 1.4. Now the equation from here we get the P2 as P1 into 1 by 3 raised to power 1.4. Here the value has been given that k raised to power 1.4 equals to 4.655. We can put as P1 is 1 and we can say that P2 equals to 1 divided by this 65 atmosphere. So this is the P2 value, but here the question is still to find the work done. What is work done? Work done can be easily being calculated by what? I'm changing the color of the pen so that it will differentiate you by the work done. Work done is in adiabatically process is P1 V1 minus P2 V2 divided by gamma minus 1. We just plug in the values as we know the P1 as 1, V1 as 1 liter, P2 has 1 upon 4.65, V2 has 3, gamma has given 1.4, and we just get the value as approximately value is 90 joules. So this is the approximately value which we are getting at 90 joules. That is, here we can see sometimes the answer are not coming exactly, it is nearby question to it. So the correct answer for this problem is 90.5 joules. So this is the answer. So this is the next question, which is from the capacitor. A parallel plate capacitor has the plates of area A separated by a distance C between them. It is filled with a dielectric which has a dielectric constant varies. It varies with Kx equals to K1 plus alpha x, where x is the distance measured from one of the plate. Where alpha d is much, if alpha d is much lesser than 1, then the total capacitance of the system is best. With the expression, we have to find out the expression from the given option. So it is in this question the dielectric is varying from one plate to second plate. How it is varying? By 1 plus alpha kx into k. X, if x is increasing, the k is increasing. We know that the capacitance value of C is, what is the value of capacitance? Yes, the capacitance of any capacitance is C is equal to epsilon naught A by D when it is air and dielectric multiplied by K. So we have to use this formula to find out the capacitance. But here the dielectric is means the capacitance has to be found for these two plates and the K is varying by Kx value. It means it has the all the capacitors are in series. All the capacitors are in series. अब सारे कैपेसिटर अगर हम इसमें स्मॉल बहुत सारे कैपेसिटर्स बन जाएंगे. अब उनको क्या करेंगे, हम सीरीज में हैं, we just simply find the effective value of that capacitance. So let us for that we consider from one plate, let the distance be x and we have to find the capacitance of this small width dx. Then what will be the value? That capacitance of that Cx equals to A epsilon naught K 1 plus alpha x divided by dx, because we are finding for the small dx. For that the effective, if we have to in series, what is the value? It is, yes, 1 upon dcx integrating. The integration is from 0 to d. So distance one plate and the second plate, the distance between them is d. We simply put the values into it. This is 1 upon c effective. We are just finding the in series. So 0 to d, we just put the value of 1 upon dx. Simply we can say 1 upon dx is dx upon A epsilon naught K 1 plus alpha x. So this is the expression. Now what is the value? Let us move next page. What is going to be the next value for this? this is the 1 upon C effective. The capacitance is equal to, as we integrated from 0 to D, we get ln 1 plus alpha D. We just put the value for x 0 to D. This is alpha A epsilon naught K. So simply this is 1 upon Cf. What is the C effective? Inverse this function, alpha A epsilon naught K by ln 1 plus alpha D. Now the question has asked the capacitance. This is the expression, but we haven't find the expression in the option. So what next? Now the difficulty has arises. That is why we are saying that the problem is little bit difficult. Now we use the Taylor's theorem. Taylor's theorem to make it C effective as x. Alpha A epsilon naught K by, we just expand it as alpha D minus alpha square D square by 2 plus like this. It goes to the higher terms. Here we simply do, we take the alpha common and make it cut. So A epsilon naught K by, we simply take D common and we get the expression as D 1 minus alpha D by 2, and we are neglecting to the higher terms as it goes to approaches to 0, so we neglect the higher terms. So this is the expression that we came across. By D we can write as 1 minus alpha D by 2, but still the answer is not coming. So what now? We use the binomial theorem. By using the binomial theorem, we can get the expression as A epsilon naught K by D 1 minus, sorry, this function is taken upside, so it is minus 1. So we just expanding this function and we get as 1 plus alpha D by 2. So this is A epsilon naught K by D 1 plus alpha D by 2. Let us check. This is the one of the expression in the answer. So A epsilon naught K by D 1 plus alpha by D. So this is the option that matching to our answer. So we can say yes, answer 2 is the correct answer. Now let us come to the next problem, that is from the individual nature of radiation and matters. A beam of electromagnetic radiation of intensity 6.4 into 10 power minus 5 watt per centimeter square is comprised of a wavelength 310 nanometer. It falls normally on the metal work function 2 electron volt of the surface area 1 centimeter square. It is square basically. If 1 in 10 raised to power 3, it is not 103, it is 10 raised to power 3 photon ejects an electron. Total number of electrons ejected in 1 second is 10 raised to power x. 10 raised to power x. We have to find the value of x. So be correct in this problem that the values for this is 10 raised to power 3 and this is not multiplication, this is power x. We have to find this value x. Now from this question we can say that energy, what is the energy? Energy is equal to hc by lambda. We know that the hc value has given, what is the value it is given? It is 1240 eV and m. So we just directly put the value as 240 eV and m by the, because the lambda also given in nm. So we directly put the values without changing anything. So from here we get the value as 4 eV. Now it is in electron volt, we can convert into the joules. Number of photons into the energy, and we have to convert into the joules, so we have to multiply by, yes, 1 electron volt is equal to 1.6. It is 1.6 into 10 power minus 19. So this much is equal to the what? This much joules is equal to the intensity into area, because the intensity is equal to what? Intensity is equal to the energy per unit area. So we have to give that the intensity is what? 6.4 into 10 power minus 5 into the area is 1 centimeter. From here we can easily find the value of n, which is come to be 10 power 40. This is, but we have to find the 10 power x, but this is not the number of photoelectrons. It is a photons, but it is said that in one photon, that is the one photoelectron is required to 10 is power 3 photons. So we directly can say that n number of photons is equal to 10 power 14 divided by 10 power 3. Here we come to be 10 power 11. So as we compare with the 10 power x, so x equals to 11. So answer here is 11. Now this problem is from the work energy part. As we see in the figure, it is saying that the particle of a mass 1 kg slides down a frictionless track, that is AOC, starting from the rest to a point A at a height 2 meter. After reaching C, the particle continues to move freely in air as a projectile. When it reaches to its highest point P, that is 1 meter from the datum, the kinetic energy of the particle is, we have to find the kinetic energy of the particle at point P. So let us see, we simply use the energy conservation. The energy conservation means, let us take the reference, this is 2 meter. From here the total energy at point A must be equal to the total energy at point P. We simply use the energy conservation. That the potential total energy at A must be equal to the total energy at P. What is the total energy at D? This is total potential energy, that is mg into h. That must be equal to the potential energy at this mg into h1 plus the kinetic energy at point P. We simply see that the kinetic energy is equal to mg h minus mg h1. We simply put the values as, what is the value? Mass is 1 kg, g height is 2 minus 1 into 10 into 1. We simply get as 20 minus 10, that is the 10 joules. So the kinetic energy at point P at this is 10 joules. So 10 joules is the correct answer. So this question is from the magnetic field, or we can say the EMI, electromagnetic induction, that we have to find the flux through the any loop. Here is the A, B, C, D, E, F, A of a straight edges has a 6 corners points, A coordinate, B coordinate, C coordinate, D coordinates, E coordinate and F coordinates as per given. The magnetic field in this region is 3 I cap plus 4 K cap, not the J cap. So we can see that the magnetic field is in the X direction and the Z direction. In J means Y direction, the magnetic field is 0. So we have to find the flux through that particular only from the X and the K. Let us see on graph, if we can draw, this could be the this is 0 0 0 and 5. This is, and this will be the coordinate. So here it is 0 0 5, this is 5 0 0, this is 5 5 0, and this is 0 5 0, and this is 0 0 5 5. So these are the x, y and z coordinates. Now what is, according to the question, we have seen that it is 3i and 4k. Electric field is from the direction this. If we have taken this as a k cap and this particular direction is j cap, and this is the I cap. So here the this direction and the k is upward direction, to this direction we have to take this area of this function and into this. Simply we know that the flux is equal to b dot a. So in in particular x direction, yani 3i direction, if we have to calculate the magnetic field, that is given as 3i cap plus 4k cap. So area vector in this direction as, in this direction it is 5 and 5, so it is 25 I cap plus again it is 5 and 5 for the k direction, 25 k cap. Simply we have to do the b dot a. B dot a, we can get the flux value as 75 plus 100, that is equal to 175, and this is the flux 75 so it is in Webers. So answer is 175 Webers. So this is the answer for this question. Next problem is from the thermodynamics. As we can say, that is from the linear expansion. In this, the question has said the non-isotropic solid metal cube has a coefficient of linear expansion as 5 into 10 power minus 5 along x-axis, 5 into 10 power minus 6, it is minus 6 along y and z axis. If the coefficient of the volumetric expansion of the solid is c into 10 power minus 6, then what is the value of? So we have to calculate the value of c in this function. So value of c can be easily be calculated as, if we get the volume from, we know that the linear expansion in x, y and z direction is given to us. Simply the volume is equal to the linear expansion in x plus linear expansion in y plus linear expansion in z. So we just put the values of alpha, that is alpha is 5. Here I can, because the 10 power minus 6 is remaining, so I just convert into the minus 6 to 50 into 10 power minus 6 plus 5 into 10 power minus 6 plus 5 into 10 power minus 6. Here the simple value which comes to be that 60 into 10 power minus 6. If we compare to the given expression, that c into 10 power minus 6, this is minus 6. So here the answer is c equals to 60. So this is the answer. So now this is the question from the thermodynamics, that is from the Carnot engine. I think you have already, if you know about the Carnot engine, the question going to be very simple. In this case, it is saying that the Carnot engine operates between the two reservoirs of a temperature 900 Kelvin and the 300 Kelvin. The engine performs at 1200 joules of work per cycle. Now the heat energy in joules delivered by the engine to the lower temperature reservoir. So we have to see what is actually the temperature here are. As we know about the Carnot engine, let us see the if you know that it has the two source and the sinks temperature, that is the source, this is the heat engine, and this comes to the sink. So the source is higher temperature, means at 900 Kelvin, and the sink as at the lower temperature, that is at 300 Kelvin. So here it is given that the two reservoirs of the temperature 900 and 300. Now the engine performs a 1200 joules. Before that, just to say what is the efficiency. Efficiency is equal to output upon input. What is the output? Here output is the work done, and what is the input? The input is the Q1. So we simply put can say in terms of the temperature as 1 minus T2 upon T1, where T2 is the sink and T1 is the source temperature. We simply plug in the values as T2 as 300 and T1 as 900. We simply get the values as 1 minus 1 by 3, which comes to be 2 by 3. So this is the efficiency we have received from this heat engine. Now this is equal to W by Q1. So we have received that W by Q1 is 2 by 3 and we can say Q1 equals to 3 by 2 W. But here what is the input and output? The input temperature, that is the heat supplied, is equal to the work done plus the sink. Here we put the values and we find out what is the Q2. This is Q1 minus W 3 by 2. Q1 is 3 by 2 W minus W. So we get the value as W by 2. W by 2. So this is the value, and we have given that the engine perform at 1200 joules. We simply put the values and we get the answer, that is 300 joules. So 600 joules. So 600 joules is the correct answer.